Let's look at some questions here for our GATE exam for some derivatives here. So a lot of these are going to have a situation where we want to actually rewrite it first, and that will make finding the derivative a whole lot easier. So for starters here, we want to take this square root of 3 on the bottom. Don't use the quotient rule. We don't need the quotient rule because there's no x down here. So if we have, we want to rewrite this first as 1 over the square root of 3 times a natural log of. Now, you might find it helpful. This is not super necessary, but you might find it helpful to, put that squared out there. There's something like that to remember that we're going to do a little chain rule going on here. Actually, you could actually use the natural log property here, but we'll leave it like it is. So the one, now let's take y prime here. Let me do another color. So y prime we're going to have the 1 over the square root of 3 here. Now remember, the derivative of natural log is u prime over u. So the derivative of the inside over the inside. So we can copy the inside down, cosecant squared. But we need to take the derivative of the inside here. And the derivative of the inside is going to take some chain rule. All right. So we're going to we're going to take the derivative first using the power here. So we're just looking at the inside. So that's going to be 2 times cosecant of x. That's the derivative of the outside. Now the derivative of the inside is cosecant. So the derivative of cosecant is negative cosecant of x times cotangent of x. All right. And so cleaning this up, we want to do some basic cleanup here. Square root of 3, this is going to be negative 2 times cosecant squared of x times cotangent of x all over cosecant squared of x, and these are going to cancel. And in the end, after some basic simplification, we don't want to don't spend your time doing a lot of extra simplifying here. We got negative 2 cotangent x all over the square root of 3. That's it. Okay. All right, moving on to 2 here. It's a good idea to maybe rewrite that square root of x as x to the 1/2. Now we've got a little chain rule going on here. Y prime, notice I didn't write y prime. You need to label this as y because we haven't done the derivative yet. Just a little rewrite. Derivative of the inside is 1/2 x to the negative 1/2 all over the derivative of the outside. Well, I should say times the derivative of the outside. The derivative of the outside is the square roots of 1 minus u, which is x to the 1/2 squared. All right. So a little cleanup here. We can take this 1/2 and we can put that 2 downstairs. And we can take the x to the 1/2 downstairs. You can write it as a square root of x if you like. All right. And then we have the square root of x, 1 minus x there. And we'll leave the 1 behind up top. All right. There you have it. And we could probably do more with it with the square roots and stuff, but for the purpose of the GATE exam, we don't need to do that. All right. So this guy, no rewrites really needed. We have the quotient rule. So quotient rule says derivative of the top, which will be negative sine x, times the bottom, e to the 3x plus x to the 4th, minus the top times the derivative of the bottom. Well, the derivative of the bottom would be, I got a little chain rule going on here. So the derivative of e to the 3x, got to take the derivative of 3x is 3. Take the derivative of e to the 3x, that's e to 3x. And that's going to be plus Let's get rid of that there. Come on. There we go. Plus 4x cubed. There you have it. All over e to the 3x plus x to the fourth squared. Remember the quotient rule? Derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. And there it is. Don't forget this. I know we've done a lot of work there, but don't forget this last little part. Derivative of 11x cubed is 33x squared. Okay, there you have it. Number 4, we've got a product rule going on here. So we're going to have y prime, no rewrites, by the way. No rewrites needed. Derivative of the first is 3x squared times cotangent of x plus the first, which is x cubed, times the derivative of cotangent, which is negative cosecant squared. That's our product rule that we just did there. Now we got to take the derivative of this part here, which is a chain rule. So derivative of the inside is 3. Derivative of the outside tangent, derivative of tangent is secant squared, and leave the inside alone. Okay, there you have it. On to number 5, this one's going to be implicit. So no rewrites needed here. Let's start here. We've got a product rule. Derivative of the first is 2x times the second, y cubed, plus the first, x squared, times the derivative of the second. Well, the derivative of the second is 3y, use the chain rule here, dy dx. Okay, got to take the derivative of the inside. That's our implicit there. Plus, now we got another product rule going on here. So let's go, the derivative of the first is 1 times the second, sine y, plus the first, x, times the derivative of the second. Now the derivative of this is going to be a chain rule. So we have the derivative of sine is cosine. So cosine of y times derivative of the inside is dy dx. Okay. And that leaves us with this right side, and that's going to be 4y to the third. Okay. Now it's time to clean up. We want to move everything that's not a dy dx term to the other side. So let's keep an eye on those. That's a dy dx term because it's a bunch of stuff multiplied. That's a dy dx term, bunch of stuff multiplied with a dy dx, I should say. So we have 2 dy dx terms. The other ones are going to the other side. So we'll rewrite these. We have 3x squared y dy dx plus x cosine y dy dx. And all the other stuff goes to the other side. 4y cubed minus 2xy cubed minus sine y. Whole bunch of junk over there. Now we're going to factor this thing. So let's factor out the dy dx, and we'll have 3x squared y plus x cosine y dy dx equals all of this stuff over here. Quick copy. Don't lose anything. And then we're going to divide by those parentheses. Divide by 3x squared y plus x cosine y. 3x squared y plus x cosine y. And we're done. Dy dx equals 4y cubed minus 2xy cubed minus sine y all over 3x squared y plus x cosine y. Here you go. All right, there's our implicit. That one's got a little bit of work there. Cruising on to number 6 here. We got a very difficult one. We got a very easy one here. But this is not the quotient rule. Do not use the quotient rule because there's no x down here. Okay, so we want to rewrite this as 1/8 x to the fourth. Now we can just do our power rule. That's all it is. It's just the power rule. So y prime is, drop the 4 down. We have 4/8 x to the third, or 1/2 x to the third. That's it. Number 7, we want to rewrite here. So this rewrite will be, we want to take all of these powers, or these fractions, I should say, with the x's on the bottom, and rewrite them as negative exponents. Things will work out a whole lot easier if you do that. So we haven't done any derivatives yet. Now this one, let's use some log rules. Watch this. You could do chain rule just fine. Chain rules will work just fine. But remember back to Algebra 2 and pre-calculus, we had some properties of logs, and that is if we have a power inside a log, we can bring that power out and multiply it, right? Now don't get confused here. We are not doing a derivative. We're not doing any calculus yet. This is not calculus. This is log rules. We can have 4 times -9, which is -36, natural log of x. We just use our log rule there. Okay? Well, now, let's find our derivative here. That -36 is going to hang out. And what's the derivative of the natural log of x? Well, it's just 1 over x. Okay? Let me rewrite. So we'll go -36 times 1 over x. That's it. Minus, go ahead. Now we do our power rule. Drop the -2, so that negative becomes a positive. X, subtract from the -2, you get -3. Watch out for that. Don't make it a 1 accidentally. And, oops, need to label that y prime. That is the derivative. We're now doing the derivative. A little rewrite would be good because we don't want negative exponents in the end. And so that's going to be plus 2 over x cubed. There you have it. Okay. Alrighty, number 8 here, inverse tangent. Again, you want to do a rewrite first because of this x here. You'll save yourself lots of silly mistakes by taking just a moment to rewrite that. Nothing to rewrite over here. We'll just leave it alone. X to the fourth plus 3x squared minus 11. And now we can take the derivative, y prime. We've got a little chain rule going on here. Got to take the derivative of the inside. Derivative of the inside is -5x to the -6th. And tangent is, remember, it's going to be 1 plus the inside squared, x to the -5 squared. We'll clean that up in a minute. Minus, now we've got our log rule is going to be u prime over u. That means the derivative of the inside over the function itself. Well, the derivative of the inside is 4x cubed plus 6x, and that's it, all over the inside, x to the fourth plus 3x squared minus 11 times, now since this is not the natural log, it's log base 7, we need a conversion factor. The conversion factor is the natural log of 7, so don't forget that. So this is pretty good. This is a correct answer, but we would like to make this a little better by getting rid of that negative exponents. And so we can say y prime equals, oh, let's see, let's drop that negative, or x to the -6 downstairs. 5, we got x to the 6th. Let's put this in parentheses, 1 plus 1 over x to the 5th squared. Okay, yeah, it doesn't do much. In fact, it might be uglier. I don't know. Oops. Minus 4x cubed plus 6x all over x to the fourth plus 3x squared minus 11 times the natural log of 7. Okay. All right. There you have it. Okay, a couple more. Almost done. So next we have a little quotient rule. It's all ready to go. No cleanup needed. We've got the derivative of the top, which is 8 times the bottom minus the top times the derivative of the bottom all over the bottom squared. Done. We could simplify it, but for purposes of this GATE exam, we don't care about simplifying it. Got the derivative. Okay. Next one. Now, notice there's no x up top there. Right? So a lot of people will do the quotient rule here and you'll waste a whole lot of time. You don't need that. So rewrite whenever you have a fraction that has a variable in it, but the variable is only on the top or the bottom, take time to rewrite it. This is 32x to the negative first. Now take your derivative. Y prime, we have a quotient rule going on here. Okay, you got derivative, I'm sorry, not quotient, product. Product, it's a multiplying. Derivative of the first is 2 times the second, e to the secant x, plus the first, times the derivative of the second. Well, derivative of the second part right here is going to take the chain rule. So derivative of the inside, secant, is secant tangent. Don't forget your x, secant x, tan x. If you just put secant and tangent, you're not correct. So that's the derivative of the inside of the exponent. So we need to multiply that times the derivative of the whole thing. And when we take the derivative of e to the x, it just stays e to the x. So this is e to the secant x. And now don't forget this last little part. It's easy to think you've just done a lot of work. You don't need this, but we've got to take care of that. So we're going to drop the negative 1, and that's going to be a plus 32 x to the negative second. And the only last thing we'd like to do is we want to get rid of that negative exponent. So we have 2e to the secant x plus 2x secant x tan x e to the secant x plus 32 over x squared. Again, there's more we could do to rewrite this. We could factor out e to the secant x and do other things, but we don't care to. Not for this exam. All right? So there you have it. There are 10 good derivatives. Keep working hard, you'll get it. Don't forget to rewrite first, in a lot of cases, to start off in a simpler place.